Yeah, I think we're live. All right. Hi, I'm Jenny. I'm the course TA for the Climate Action course. I'm here with Dr. Valerie Masson-Delmotte. She is a lead researcher at the IPCC. To those who are joining in with us live, you are more than welcome to post questions and interact with us. And we'll be addressing your questions as well as the questions that have been posted on the discussion board. So first, Valerie, thank you for joining us. Could you please introduce yourself a little bit and talk about your background and how you became a researcher at the IPCC?
Hello to everyone, and thank you for your time and having this moment together. So I'm a climate scientist. I have a background in physics, and since 1993, I've been working at the same place at University Paris-Saclay, south of Paris, in an institute working on climate research, basically. My own work has been focused on understanding past climate changes and benchmarking climate models that we use for future projections against past climate changes. I was involved in the IPCC as a lead author for the 4th assessment report, as a coordinating lead author for the 5th assessment report, both on the chapter on past climate. And I was elected in 2015 as a co-chair of the working group 1, which is on the physical science basis. So I'm still a scientist in my office, in my department. You can have a look here at my beautiful office in the suburb of Paris, about 20 kilometers south of Paris. And I spend almost all of my time now supervising the preparation of IPCC reports for the 6th assessment cycle.
Thank you. Can you explain to our viewers what exactly is the IPCC and the whole process and how consensus is reached, where scientists get their evidence from, since it is about modeling the future? Like, how can you tell?
Yes, so the IPCC is the Intergovernmental Panel on Climate Change. It's a science body. It was established about 30 years ago in 1988 under the auspices of the World Meteorological Organization and UNEP, so the UN Environmental Programme. I describe the IPCC process as a co-design between governments and scientists. So we prepare assessment reports. We don't do new research or new science as such. We assess the state of knowledge. And for that, we ask a number of volunteer scientists, authors, to work from the scientific, socioeconomic, and technical literature. And so they assess the state of knowledge from the literature. They do it in the most possible rigorous, exhaustive, objective, and transparent way. What is key for the IPCC process is its review. So each report is reviewed in multiple steps by volunteers from the scientific community and by experts nominated by governments. And at the end of the process, the summary for policymakers is approved word by word and sentence by sentence on the basis of scientific facts from the literature, with a final word to authors of the report in a plenary session with delegates of all governments. For instance, for the last reports that we have prepared, the special report on global warming on 1.5 degrees Celsius, it has been prepared by 90 scientists from 40 different countries. They have asked 133 contributors to help them. They are called contributing authors. And they have assessed about 6,000 peer review references. And the report has been reviewed by more than 1,000 experts. And they have contributed more than 42,000 review comments, and each of them has been considered by the authors. So that's the process, and that's why I describe it as a co-design. Sometimes there are misunderstandings. For instance, the notion of consensus is sometimes difficult to understand. So what the authors do is that they assess the evidence, the agreement from the scientific literature, and they report what is in the scientific literature. That's a way to describe, for instance, scientific controversies. Usually each chapter ends by an assessment of the limits of knowledge, knowledge gaps, key sources of uncertainties, which are, in fact, new research directions for the future. And so each statement, each key finding of the IPCC is traceable to the source literature. So you see the list of papers that have been assessed. the conclusion is expressed with a specific calibrated language. For instance, low confidence, medium confidence, high confidence, or a statement of fact. Sometimes it's also using a probabilistic language to express in a quantitative way the level of confidence. Very likely has a specific meaning in terms of probabilities, typically. So this is traceable to the literature, and sometimes there's an expert judgment of the team of authors who agree on the level of confidence associated with what is available from the evidence and the agreement of the evidence.
Can you comment a bit on people who highlight the so-called the scientific uncertainty of climate change? You mentioned that in the reports, IPCC reports in general, that sometimes authors might say that something is medium certain. Does that mean that it's like not going to happen, or that it's just a reflection of the vast literature that's out there?
Can we use the slides that I had prepared? And if possible, to go to the slide number 4. So I'll describe more precisely how the confidence level is evaluated. So the first thing, from the literature, the authors evaluate the evidence and the agreement. Then they synthesize the findings and they assess the confidence with a qualitative judgment. So this is on the slide. Yes, this one. The next one, please.
Slide 5, okay.
Exactly. And so they assess the type of evidence. It's not counting papers. It's really looking at the scientific elements in each paper, the quality of the evidence, the consistency. And so, of course, if you have limited evidence, low agreement, you have no confidence in a finding. If you have robust evidence and high agreement, you have very high confidence in a finding. And then there's any shade of gray in between these sort of extreme ranges for confidence. So when we assess that something is associated with a medium confidence, it does not mean it's very uncertain. It means that we have limited evidence, and sometimes that not all the evidence is in perfect agreement. It can mean, for instance, that we have limited observational data sets, or limited understanding of the processes, or that we have models that do not fully represent the processes at play. And so for each finding, either we report just the evidence and the agreement. Sometimes we can assess the confidence and it is reported. And in fewer cases, when we have, for instance, several data sets, or we can compare model results, we can evaluate the likelihood of a specific finding. And the language that is used here can be translated in a probability of the a probability range, basically.
Thank you for answering that. It was a very thorough explanation of something that I'm sure a lot of people who aren't experts, they definitely they read these reports and they're like, well, it sounds medium certain, so maybe it's not even worth believing. But it seems like this is a result of a rigorous reflection of all of the available evidence. So moving on to the 1.5 degrees Celsius report, can you explain a little bit why the 1.5 degree target was included in the Paris Agreement and why the IPCC decided to do such a vast study of this target, and in terms of impact, the differences between 1.5 and 2 degrees Celsius of warming?
So it's difficult to give a comprehensive answer in a few minutes. My understanding is that at the time of writing the Paris Agreement, governments from various countries did not agree on a single long-term target. So the long-term target of the Paris Agreement is to limit global warming above pre-industrial to well below 2 degrees. And there is the clear expression of an aspiration to limit warming to 1.5 degrees Celsius. And in the negotiation process, this reference to 1.5 degree of global warming came from countries who perceive themselves to be particularly exposed and vulnerable to the consequences of a changing climate. For instance, the least developed countries or small island developing states who are exposed to compound risks, for instance, associated with sea level rise, but also changes in the local water cycle, or extreme events. And at the time of the Paris Agreement in December 2015, there was limited knowledge on what would be the impacts of a 1.5 degrees Celsius warmer world, what would be the avoided risks if warming would be stabilized at 1.5 compared to 2 degrees, and what would be the greenhouse gas emission pathways compatible with limiting warming at 1.5 degrees Celsius. There was some evidence in the 5th IPCC assessment report for 2-degree warming, but very little evidence, very little information for what, in fact, why half a degree would matter. So as a result, as part of the decision of COP21, governments agreed to invite the IPCC to prepare a special report on impacts of 1.5 degree of global warming and associated greenhouse gas emission pathways. Then, in the following spring, beginning of 2016, during a plenary session, government delegates within the IPCC decided to prepare a set of 3 special reports for this cycle, including a special report on global warming of 1.5 degrees Celsius, so to accept the invitation from COP21, but to put it specifically in the context of the global response to the threat of climate change, sustainable development, and efforts to eradicate poverty. So governments wanted to have not just a focus on climate change and response options, but also how they interact with sustainability and the first Sustainable Development Goal in relationship with poverty. So this, the COP21 decision and the decision of the IPCC to prepare this special report have also been a clear signal for the international research community. So in the last years, in the last 3 years, many research programs, many new publications have provided new knowledge. For instance, looking at climate simulations, those that were previously available, stopping when the level of warming is reaching 1.5 degrees Celsius or 2 degrees Celsius, and looking at the differences in regional trends, looking at the differences in extreme events, looking at the implications for sea level rise, and then crossing the information on climate hazards with information on future trends in exposure, future trends in vulnerabilities. It provided also new knowledge on changing climate risks and how much they depend on the level of warming. So in the 1.5 special report, it's all available online on the website of the IPCC, www.ipcc.ch. You can look at Chapter 3. Chapter 3 of this report is focused on impacts and risks, and the comparison between where we are today at about 1 degree of global warming, what would be the implications of half a degree warming, a 1.5 degree warmer world, or multiple 1.5 degree warmer world, and then what would a 2 degree warmer world imply, and what are the differences. And the findings were a surprise, even for my own research community in climate science, how much half a degree matters in terms of regional climate change, in terms of changes in extreme events, such as heat waves, heavy rainfall events, and in some regions, droughts. So there are clear differences between a 1.5 and a 2 degree warmer world and compared to today. Some regions are facing disproportionately larger risks. It's the case for the Arctic, semi-arid countries, countries with a Mediterranean climate, small island areas, some areas in the tropics as well. And our report concludes that there are clear benefits in terms of risks and avoiding risks at stabilizing the level of global warming as low as possible, or in other words, each additional half a degree matters in terms of climate risks.
All right, thank you. To everyone watching, we have been assigning the 1.5 degree special report, but I will include a link to Chapter 3 if this interests any of you climate actors.
You can also put the slide 8 of the PowerPoint, because it's a summary of some of the assessment as well.
Sure.
If you can still navigate through the slides.
Sure.
Thank you. So this is just a summary for some of the key natural, managed, and human systems that shows how the level of risk is changing as a function of the level of warming. And you can see severe risks, for instance, for tropical coral reefs, or for the Arctic region between now and 1.5 degrees of global warming. I can also mention that in Chapter 3, you also find maps showing differences in regional climate and very specific assessments per region, specific assessment per sectorial activity area, a table of regional hotspots and tipping points as a function of the level of global warming as well.
All right, thank you for this summary. And do you know what chapter this diagram is in?
It's in the summary for policymakers, but it's also detailed, and you can see exactly why this level of risk is assessed in Chapter 3 on impacts and risks.
Okay, awesome. So now that we've made clear the risks and the huge difference that half a degree can make, and just the impact that this has on the livelihoods of people around the world, but also the great opportunities that I guess become available here if people act now. Can you comment a bit on the findings of this report on what we have to do to limit warming to 1.5 degrees? Can you discuss like what pathways we can take?
Sure. So the first thing I wanted to add is with respect to the assessment of changing risks, there are already response options in terms of adaptation and strengthening resilience. There's a diversity of options. They depend, of course, on the context and the sector, but the report also provides a detailed assessment on the opportunities in terms of adaptation and the adaptation needs. So if we look at the options to stabilize warming to such a low level, you can move to slide 9. And I have to explain that the future level of global warming will depend on two things. It will depend on cumulative emissions of carbon dioxide, CO2. Carbon dioxide has a cumulative effect, so that the peak level of future warming depends on the sum of past, present, and future CO2 emissions. So if you want to stabilize warming in the future at any level, you have a certain amount of CO2 emissions altogether that is compatible with this level of warming. And in other words, it means that if you want to stabilize future climate change, global CO2 emissions have to decrease and to reach net zero. So this figure from the summary for policymakers illustrates in blue a diversity of pathways that are compatible with limiting warming to 1.5 degrees Celsius with a 50% chance. And you can see that they all show a peak in the coming decade, a decline by the mid of this decade, a significant decrease by 2030 by about a factor of 2, and reaching about net zero around 2050. If you would like to stabilize warming at 2 degrees or well below 2 degrees, it's basically the same characteristics of pathways, but with a slower pace, decreasing global CO2 emissions by about 25% by 2030 and reaching net zero CO2 emissions by 2070. And this figure also shows that if we delay such action, for instance, by starting a reduction in CO2 emissions only by the end of 2030, then it is not shown, but it implies that the level of warming would overshoot 1.5 degrees Celsius. And the only option that would remain available to go above 1.5 degrees Celsius in the coming decades and then back would be the ability to eliminate CO2 from the atmosphere and store it on the long term. So it would be the ability to deploy something called negative emissions, and that's why the gray curve shows negative net human emissions of CO2 in the second part of the century. Today, these technologies are not available. It's not clear how much they would cost, and some of the options for negative emissions might create new risks. For instance, if they rely on the large-scale use on biomass, so using energy of biomass to produce heat or to produce electricity, then capturing and storing the associated CO2 emissions. So that's an important element in our assessment. The second factor that will define the level of warming in the future is the net effect on climate, and we measure it by something called the radiative forcing. So it's a way to measure how much emissions of a given substance affect the radiative budget between the Earth and space. And so the first thing is to go to net zero for CO2 if you want to stabilize warming. The second thing is to decrease the net effect on climate, so the radiative forcing of other warming agents. They can include methane, nitrous oxide, so 2 other greenhouse gases, or black carbon, aerosols that have a warming effect. So this is illustrated also on this figure. The fact that to stabilize warming at such a level as 1.5 degrees Celsius above pre-industrial, you need to act very sharply on CO2 emissions, but you also need to act and reduce emissions of methane, black carbon, and nitrous oxide in the coming decades.
Thank you for that explanation. It sounds to me like the result of this research is saying that the time to act is now, and every day, I guess, that we delay is another day that in the future we will have to depend on technologies that are either not really fully developed yet, or I guess technologies that will inevitably depend on the deployment of renewable energy, I guess, for if you wanted to take carbon dioxide out of the air.
You can also see it in another way. I mean, reaching or going above 1.5 degrees Celsius is not already committed. If we would stop all emissions now, global warming would continue a little. Sea level rise will in any case continue, but the level of warming will not go above 1.5 degrees Celsius. So it depends on what we are going to do in the coming decades. We still have a small window of opportunity if acting together at an unprecedented scale to decrease CO2 emissions. If we don't act now, inevitably, the level of warming will go above 1.5 degrees Celsius, with potential irreversible consequences in terms of fragile ecosystems, such as coral reefs, and in terms of risks of crisis for the most fragile of human societies.
Right. And the impact of coral reefs at 1.5 degrees, my understanding is that 90% of coral reefs will disappear, but at 2 degrees, all of them will be gone. And
yeah, the word disappear is too strong. What biologists say is that by having more frequent, more intense, and longer marine heat waves, the coral reefs would undergo degradation, and so they would not be as they are today, with the same biodiversity as they have today. So the word used by biologists is a risk of severe degradation of between 70 and 90% of them at 1.5 degrees Celsius warming, and almost all of them in the tropics for 2 degrees Celsius warming.
Okay, thank you for clarifying that. So before we move on to, I guess, the what can be done, we do have some questions from the audience that I would like for you to address, if you can. So this is a multi-part question. There is a recent report published by the UNEP that discusses the melting of permafrost on the poles. And it seems like it's saying that if we stuck to the Paris Agreement, the Arctic winter temperature will be 3 degrees higher than average. A few questions. First, is this the same as mean temperature year-round? Winter temperature, I guess, compared to mean temperature. And second, that this UNEP report is based on a 2-degree scenario. So is this still like a risk, I guess the risk of melting permafrost releasing carbon dioxide and methane? Is this still a risk at 1.5 degrees? And there are people who interpret this to mean that that because you can't avoid the melting of the polar ice sheets, that that action is kind of pointless. Can you comment on these tipping points and on this attitude that there is, it's not just impossible to take action, but that it's like not even worth it?
So for permafrost, permafrost is frozen ground. It's present in some high mountains. It's also present around the third pole, and it's present at the large scale in the Arctic. It's basically a memory of past ice ages. And so what's happening today is due to warming. There's a process called thawing of permafrost. It can create local risks on infrastructures by changes in the topography locally. It can also be associated with coastal erosion in some cases. And this permafrost contains organic matter that was kept buried and frozen. If there's water percolating around, if this organic matter is exposed, it can be decomposed by microbiological organisms, and it can release different greenhouse gases depending on the hydrological context, the type of microbes, and the type of soils, basically. So this issue is important because for a certain level of warming in the future, if these areas emit greenhouse gases, it means that our margin of action in terms of our own emissions of greenhouse gases is reduced in terms of compatibility with a certain level of warming. So in the 1.5 special report, in chapter 2, the chapter on greenhouse gas emission pathways, there has been an assessment of the state of knowledge with respect to the potential release of greenhouse gases in a thawing permafrost associated with a level of warming between 1.5 and 2 degrees compared to today. This is based on a number of different lines of evidence. What's, for instance, quite new is reviews of all studies where people have taken frozen soil samples, studied them in laboratories, basically increasing the temperature of the soils and monitoring over several years what has been the degradation of the organic matter and the associated pace and amount of greenhouse gas emissions. So these type of studies are new, and they have been considered together with the work done in terms of permafrost modeling, which is still associated with a number of uncertainties. So this has been partly assessed, both in terms of different implications for permafrost, for different amounts of warming, and implications in terms of greenhouse gas emissions. Of course, the more we perturbate the climate system, the more we add greenhouse gases, the more we enter in what the World Weather Organizations calls unknown territory. However, in our current understanding, the amount of greenhouse gases emitted by permafrost would remain limited for this century for 1.5 or 2 degrees of global warming. It would be larger with larger levels of warming. So there's consistency between the assessment of the 1.5 report for what it looked at by mandate and what the UNEP recent report has released. And I want to stress that the IPCC is currently preparing a special report on the ocean and cryosphere in a changing climate. So the cryosphere is related to snow, ice, sea ice, glaciers, and permafrost. So there will be a specific and new assessment of how we understand processes to act on changes in permafrost and permafrost greenhouse gas emissions. And this report will be approved, hopefully, in September this year. So it will be an opportunity to look at the current understanding as a function of different levels of future warming. And in the points that you have touched, it was not just about permafrost, but also about ice sheets. So ice sheets, in this case, we speak about land ice that has accumulated over Greenland or Antarctica. So it consists of snowfall accumulated over thousands of years. In a warming world, there are two factors that can affect what we call the mass balance of these ice sheets. One is melt. When you are above 0 degrees Celsius, you can have melt and flow of water. But there's also a process due to warmer ocean temperatures that can affect the floating parts of these ice sheets. They are called ice shelves. It can cause them to be thinner, to flow faster, and to drain ancient ice from the inland part of ice sheets faster. So at the moment, we see that there's a growing contribution of the Greenland and Antarctic ice sheets to sea level rise, and it's responsible for an acceleration of sea level rise in the last decades. So the pace of sea level rise has accelerated from around 2 millimeters per year in the 1970s to more than 3 millimeters per year in the last decades. There are huge questions about how much and how fast the Greenland and Antarctic ice sheets can contribute in the future. We know there might be thresholds after which this could lead for Greenland to irreversible loss of ice, and for some sectors of Antarctica that are potentially unstable in terms of ice flow, sustained long-lasting contributions that could be several meters of sea level over time scales of centuries to millennia. However, now, we do not know if we have already passed such thresholds where they are. They are probably in the range between 1 degree and 4 degrees of global warming. That's the evidence from past warm phases in the Earth's geological history. And so this is a topic which is associated with something we can call deep uncertainty. So we have limited evidence. We have limited understanding of the processes at play. We know that this is physically plausible, but we don't know exactly when it would start, when it starts to be irreversible. And if it started, then we can assess how much sea level these ice sheets could contribute in the future. So I would not say that it means climate action is not relevant. It means that it's very important to make progress in understanding these things in terms of research, monitoring, improving the tools that we have, especially ice sheet models. It also means that it's important to take this uncertainty into account for decision making. So what's emerging in the world of decision makers is a process of robust decision making under uncertainty. It is the case in particular for coastal management. I finally have to stress that we have limited uncertainty and on the amount of sea level that is expected in the next decades. But the more we go in the future, the end of the century and beyond, the larger the uncertainty is. And it's important to consider when implementing choices in terms of coastal adaptation.
Thank you for that very detailed explanation of a topic that I'm sure a lot of people who study climate change, they think about a lot. So you said that the impacts in the short term, and by short term, I think we both mean the coming decades, the next 30 years, I would say. Those impacts, if I understand correctly, are known. And because of that, it should create the impetus to take climate action now.
Yes, because what is needed is to strengthen resilience for economic sectors, for infrastructures, for human activities. And this needs to take into account climate information, including the uncertainty that is there, to guide adaptation strategies. And this is no regret. Climate is going to change. And on the near term, we have a good understanding of the pathway and of the climate trajectories. So it's really important to consider the climate information available now, anticipate and develop strategies to reduce climate-related risks by acting on vulnerabilities, by acting on exposure. On the longer term, obviously, we are in an unknown future because the climate trends beyond basically 2040, 2050, they will strongly depend on what we do in terms of greenhouse gas emissions in the coming decades. If we do not reduce emissions, there will be an acceleration of climate change. If you reduce strongly emissions, we can stabilize it. And that's really the main challenge in terms of where are we going to.
Right. And you said at the beginning that the IPCC process, it was also a reflection on how climate change relates to other world problems like poverty. And the Sustainable Development Goals, there are 17 of them, and they do relate together. Do you believe that taking on this challenge of climate change, if it is done holistically, it can be a process that can also achieve the eradication of poverty, for example, which is a goal that like we aim to have at 2030, which I think coincidentally is also the window for climate action that was described by the IPCC.
Yes, this is really where I think the report is novel. So it's first novel in looking at the opportunities for action, combining adaptation and mitigation, so systems transitions. And this has been analyzed through 6 dimensions of feasibility. And it shows what is available now and the barriers to overcome to facilitate the deployment of these response options in the future. That's our chapter 4. And our final chapter is focused on sustainable development and climate action. And so it shows that amongst the portfolio of action for adaptation, for mitigation, each option can create benefits for other dimensions of sustainability, but some of them can also create trade-offs. So what's really relevant is to not just think of climate action as something separated from the other world goals, but to look at them and map what are the win-win options, where, for instance, by reducing some greenhouse gas emissions or some emissions of warming factors like black carbon, you can quickly improve air quality and therefore have immediate benefits in terms of public health. Let's take a second example, food systems and agriculture. There are a number of options where you can have healthy diets, so good nutrition, and at the same time, you can have these diets that provide benefits in terms of avoided greenhouse gas emissions. So this is another example of a win-win action. Basically, if you follow a doctor's prescription for what is a healthy diet, it's also a diet that is better in terms of environmental footprint and emissions of greenhouse gases. So these are 2 examples, but there are other things that are really important. For instance, access to affordable energy, energy poverty that is present even in rich countries, and how to deploy a strategy to reduce greenhouse gas emissions while protecting those most vulnerable, allowing access to energy and allowing to surpass energy poverty. So the notion that is developed in the report is the notion of climate resilient development pathways, where you put a specific emphasis on those most vulnerable to climate change, most vulnerable to public policies that aim to reduce emissions. And that's a key for bringing everyone together, for improving well-being for all, while going towards net zero CO2 emissions. And what's really surprising in the current situation is that thanks to new technologies, thanks to new developments, it is possible to have climate action going hand in hand with achieving other world goals. And that's something that's really powerful in terms of message. It doesn't mean you have to compromise access to energy or climate action. If you do it well, if you favor low carbon energy options, you can do both. And I think that's really one of the novel aspects of the assessment in this report. So I summarize it, with the following things. Each half a degree matters in terms of risks. Each year matters in terms of emissions. And finally, each choice matters. And it's possible to design, in each context, a portfolio of options to maximize benefits in terms of sustainability, or in other words, to create ethical and fair transitions. And that's really a challenge because at the moment, many public policies, they are operating in silos. You have on one side a climate policy, on the other side a public health policy, on the third side a policy to preserve biodiversity. And what we show is that there's a huge potential by not operating in silos, but identifying strategies that maximize benefits in multiple dimensions.
Thank you. That was a really good explanation. Can you comment a bit on the models for regional and local scenarios? Like, is this something that can be done at a local model, like a local level and scaled up, like, for example, at the level of cities? And what kinds of actions can be taken at a level, because, you know, at different policy levels, I'm sure things might not move fast enough. Can you comment on scale, I guess?
Sure, that's a very important element, and we show in the report how much the coordination across scales matters. There are things that belong to international agreements, national policies, land use policies, and a lot of things matter at the scale of cities and communities. For instance, exploring climate-related risks only makes sense at the scale of communities or cities. They are really different depending on the geographical context and the way these cities are developed. And so at the moment, we see really the emergence of new methods to identify downscale climate projections and develop information that is relevant to understand climate risks at city scales. So locally and also through interconnections. In terms of greenhouse gas emission pathways, what has been assessed in our report are global pathways. And there's really a need to decline them at the national scale or at the city scale. So basically to build scenarios at the city scale on what are the main risks that one wants to avoid, what would be the targets in terms of greenhouse gas emissions, and then identifying what are the tools for action in terms of building, in terms of industry, in terms of transport, in terms of food systems, in terms of the multiple dimensions that are important at a city scale. I know at the moment there are huge efforts to work on so-called deep decarbonization pathways at national levels. And I can also see the emergence of these approaches at city scale. Last year, we organized an international conference on cities and climate change science, and we have proposed a research and action agenda. So if you go to the city's IPCC website, you can find the recommendations from this conference on how to better bridge between the academic world and practitioners who operate at city scale, so that there can be an intersection between the local knowledge, the academic knowledge, and methods and tools can be developed to inform local strategies.
All right, thank you. So I guess it seems like there is a lot of hope for the future if we act soon and act fast. How do we get emissions down to the levels that are described in the report?
So the report shows that there's a need to implement transitions in the main systems, energy systems, land use systems, including management of forests, agriculture and food systems, industry, infrastructures, and urban systems as well. So that's something that's in terms of structural changes. There's also another dimension, which is not of the supply side, but also the demand side. And there's a huge potential to act by also changing the demand side. So having more sustainable patterns of consumption, basically. Choices that reduce the demand for energy by acting on energy efficiency as much as possible. Reducing the demand for non-renewable material. And by reducing the demand for animal proteins, that's an important element of the climate footprint of food systems. And in our assessment, we show that basically when you act on the demand side, then you have smaller production systems that are easier to transform. So that's something that's, I think, quite novel. And that's also in relationship to another scale, which is the scale of individual choices, the scale of citizens, basically. So it's not just about governance, but it's also about choices, lifestyles, behavior changes. And we show in the reports that the pathways where you act on the demand side they are the pathways that maximize the benefits in terms of achieving the Sustainable Development Goals for all.
All right, thank you. So you're saying that smaller systems are easier to transform. I think that is a very simplifying but also kind of hopeful way to think about this issue, is that there is no reason to despair, that if people demand the future that they want, people will listen.
Yeah, and then I can express my own view. And my own view is that there's a clear need to strengthen education related to climate change. You know, at any level of programs in schools, because basically we need to make visible what is invisible. So greenhouse gas emissions, they are invisible for most people. So it's important to have tools so that they understand which aspect of a lifestyle, of a choice, an individual choice, but also a collective choice, how much each of these aspects matter in terms of emissions. Otherwise, you cannot understand where you could act and how to act. And the more you emit, in fact, the more you have the ability to reduce your emissions. And that's an important point. I think it's an important point also in relationship with Sustainable Development Goal 13, where education to climate change is mentioned as one of the three priorities, if I get it right.
Yes. And moving, I guess, going off of that about education, we did get a question from one of our students about how the authors explain that they explain global warming in a pedagogical way to be used in education. This is referring to the 1.5 degree summary for teachers, which is very comprehensive, super easy to read, but also really fully like explains the weight of what needs to be done. So how can we convey the message in a similar way for politicians at all levels?
So we had the organizations of large cities. They have also developed a summary of the 1.5 report for cities decision makers. So it's an adaptation of this report in the context of action at the city scale. It's also done in a pedagogic way with examples that show how it can be grounded in a specific context. I'm really glad that the Office for Climate Education has worked on the 1.5 report, trying to develop educational pedagogic material. We also have frequently asked questions. We have 10 of them in the report. That's also something quite helpful. In terms of ownership of the report, I'm also stressed. I would also like to stress that in France, some citizens have done their own translation in French of the summary for policymakers. So they have a wiki link, and they have done a collective and a reviewed by themselves translation. I know it's happening in Portuguese. So the report will soon be translated for the summary for policymakers in the 6 UN languages, so Chinese, Russian, Arabic, Spanish, French, and in addition to English. But there's a possibility to use the wiki model that has recently been developed if some people are interested to translate in other languages. Because we have the barrier that it's mostly produced in English, it's the language of most scientists. But it's important to make it accessible because there are lots of elements in this report that really would benefit by being shared in the native language of many people in the world.
All right, that is excellent. Definitely, it's super important to make sure that this is something that people understand, and people won't really understand it unless it's in their native language, which is a really good point and a very interesting model for future reports. So can you discuss a bit what reports will be published by the IPCC in the coming months or the coming year?
Yes.
You mentioned one about the ocean.
Sure. So if you can, I think in the slides I provided, if you can show the slide number 6. Sure. So I want to stress that the IPCC has a task force on emission inventories. It's an important aspect. It's about how can you estimate the emissions at the national scale by inventories for each sector of activity. So this group is finalizing an update of the methodological report on greenhouse gas emission inventories, and it will be approved next May, so it's coming soon. Then in August, we will have the approval of the special report on climate change and land. So it has a number of chapters on desertification, land degradation, food security, which is also touching food systems, diets, and nutrition. It has a chapter on sustainable land management and a chapter on risk management related to land and climate change. And it also has a chapter more on land, climate, multiple interactions. So I call sometimes this report, climate change from my landscape to my farm, my plate, and the waste that comes from that. It's about how much, it's about the challenges in terms of adaptation. It's also about the opportunities of transformation so that we use land in a sustainable way to provide food for people, to preserve land-based biodiversity, and to store carbon, which will be the main pressures in the future, in addition to using land to produce energy. So it's an important report, and it's being finalized. We have a workshop on preparing the summary for policymakers next week. And then in September, we will release the special report on the ocean and cryosphere. So it has chapters on high mountains, polar regions in the Arctic and the Antarctic, coastal areas with sea level rise, oceans, ocean ecosystems, and people who depend on them. And finally, related extreme events and risks of abrupt changes. So this report will focus on risks, resilience, and adaptation options. It does not include mitigation apart from blue carbon, which is a way to enhance the ability of coastal ecosystems to store CO2 from the atmosphere. So this is the set of reports that are under preparation. It's an unprecedented effort from the IPCC. And after that, and in parallel, in fact, we are also working on the main working group reports. So the physical science basis, our first draft will go under review this spring. Climate change impacts, adaptation and vulnerability, and mitigation of climate change. It's also going to go under review by the end of this year. And all these elements will feed the synthesis report of the 6th assessment cycle of the IPCC in 2022, in time to inform the global stocktake of the UN Framework Convention on Climate Change in 2023.
All right, thank you. So I guess to summarize what we've been talking about, to those people who say, like, why should we trust the IPCC? I guess the response is, well, you should, because it's a collaboration of many scientists who've looked over thousands of references, and they've all come to basically the same suggestion, which is that the time to act is now and we should not delay. That the form that this climate action will take in the future can take on novel ways and strategies, and that there are many opportunities for transformation in the future. Is there anything you would like to add? Would you like the last word on this?
Thank you very much for giving me the opportunity to share basically the careful approach where we assess the state of knowledge. The super peer review process, that is a strong element of confidence for the IPCC assessments. And I want to stress that our reports, they are by mandate designed to be policy relevant, but they are not policy prescriptive. So we show basically a broad portfolio of options, and there are multiple choices that can be made in different contexts, depending on your own views, your own values. And we also show how important it is to include climate action within the broad envelope of sustainability, looking at the benefits of climate action in multiple dimensions of sustainability.
All right, awesome. Thank you so much for joining us and for answering all of our questions. This was a great discussion, and I hope we all learned a lot.
Thank you so much. And it's an important day because there are young people around the world taking also action now. So thank you for this opportunity to discuss the topic on a special day.
All right, thank you so much. I hope you have a good weekend.
Thank you. Bye-bye.
Bye.